Ready to get started with AI and the latest technologies? Microsoft Reactor provides events, training, and community resources to help developers, entrepreneurs, and startups build on AI technology. Learn more by visiting aka.ms/InfoQ/Reactor.
Hi everyone, my name is Srini Pinchikala. I am the lead editor for AI, ML, and data engineering community at the InfoQ website, and I am also a podcast host. Thank you for tuning into the podcast. In today's episode, I will be speaking with Namee Oberst. Namee is the founder of AI Bloks, the company behind the open source LLM framework called LLMWare that is used for Gen AI based applications in financial services and legal industries. We will discuss the topics of current state of language models in the Gen AI adoption, and more importantly, the recent emergence of small language models, or also called SLMs, how these new type of language models compare with the large language models that we have been familiar with for last few years, and more importantly, how these smaller models are enabling mobile devices and edge computing servers in leveraging Gen AI solutions that have been limited to large language models until now. Hi Nami, thank you for joining me today. Can you introduce yourself and tell our listeners about your career and what areas have you been focusing on recently?
Hi, Srini. Thank you so much for having me on. It's such a pleasure to be here. I'm Namee Oberst. I'm the co-founder of AI Bloks. And as Srini mentioned, we are the folks behind LLMWare. We are an open source project, and our mission is really to make generative AI easy to use, easy to deploy, and easy to really develop. And that's all for the enterprise and for regulated industries. And we really emphasize development and deployment securely, safely, and cost effectively. And we've been focused on using small language models. We're really one of the pioneers of doing that. We started 20 months ago. We launched an open source about a year ago, but we really started our work to prepare for launching really well before that. And a little bit about my background, I think, will be helpful in why and how we came to focus on small language models. So I started actually as a corporate attorney working at Big Law. And in working in Big Law, I had a lot of repetitive tasks, really boring, mundane tasks that, to be honest, like soul crushing. Like I loved working in my big law firm for the camaraderie, for the colleagues, and I loved the perks of all that. But honestly, there were so many repetitive tasks that I was doing. And that was almost the motivation behind starting an AI company, thinking, there are so many, for knowledge workers, so many repetitive tasks that could be automated. Why aren't we doing that? So that's really the impetus, the aha moment. But then the second aha moment was because I was working with a lot of highly regulated industries and large corporate clients, I also knew that, the ChatGPT way of sending out all this potentially sensitive data out was not going to fly to a lot of enterprise customers. Like, I know how lawyers think because I am a lawyer. So I thought there is just no way that this is going to be sustainable for the long term. So we really looked at small language models from the beginning and how small language models could do very focused and targeted tasks like, let's say, contract analysis as an example, right? Like, could I have small language models like review, 200 documents and tell me, are these contracts assignable, or what is the state of jurisdiction, or, give me some concrete facts and do a lot of information retrieval. And we found, lo and behold, they could. And even 20 months ago, we were finding that they could, in some ways, more reliably and predictably than our OpenAI calls, because OpenAI had so many outages. And we were like, if you ping it like 100 times, we were getting no responses back for 30 to 20% of the time. At that time, OpenAI also had significant issues with accuracy as well. So we were looking at it thinking, wow, like this model that you can run actually locally can actually produce very comparable results if you have a very specific use case in mind. So that's how we really kind of started down this path. And so not surprisingly, when we launched an open source, one of the first things we also did is release a whole bunch of RAG fine-tuned models. I think we're the first to even do that as well. And our first RAG fine-tunes are called Dragon, and they're like 7 billion parameter models that are specifically trained to not hallucinate, to really only answer the facts, and with quality scores. Because the idea is we wanted the users to have the kind of accuracy that you could get from basically a corporate lawyer. Like if you had another lawyer or a very intelligent colleague working alongside you, like a coworker. So that was kind of the idea behind using small language models. And then since then, we really evolved to then smaller RAG fine tunes. And then most recently, are very small function calling models that are 1 to 3 billion parameters that can really kind of step in and help you automate a lot of your workflows and processes. And that's a very interesting space that we're getting a lot of usage on. And I think a lot of our community members really like that as well.
Thanks, Namee. I think this is probably the first time I think we have a guest, who is not only passionate about the innovation side of the AI space, but also has the attorney background, to kind of comment on, opine about from the regulation and compliance side, right? So it's a great combination because we need both of them, right? So I definitely want to talk more about the small language models. I'm very excited about this because like any other innovation in other technology spaces, I think the small language models have a lot of potential to make a big impact in the overall adoption of these solutions. But before we get into the main discussion, let me set some context for this discussion with a quick background on small language models. So as we all know, large language models or LLMs have been one of the major innovations in AI and ML space for the last few years since GPT and ChatGPT were released. And they kind of took the software world by storm, right? By introducing the power of generative AI technologies compared to the traditional predictive AI that we've been doing for a long time. Now we are seeing it being used in so many different use cases. And also we have witnessed the LLMs are being dominantly used in various business and technical use cases to create exciting new opportunities that we have never even thought about before, not only for the end users, but also for software engineers, the DevOps engineers and other groups to be more productive. So they have empowered, pretty much the full life cycle of the process. So LLMs are powerful, but they do come with some challenges, right? So mainly they require the significant computing resources to operate. You cannot just run it on a small machine or a small cluster of machines. That's why only the big tech companies are able to fully leverage these technologies. And also there's a privacy factor also. You have to send the data to the cloud to leverage these LLMs, and sending the data may not be possible or allowed, for most of the use cases in the companies. So that's where these LLMs are not the best choice. The latest trend in the language model evolution are the small language models or SLMs that offer many of the same benefits as LLMs, but they are smaller in size, they are trained using smaller datasets, and they don't require a lot of computing resources. Again, these models are obviously not for every use case out there. I mean, they're not one size fits all solution, right? So, but they are very valuable for some use cases where you have a constraint on the resources or you want to localize the model execution. They're going to be of great help. And then I think they also are opening up a lot of new opportunities to run the SLMs on smartphones and other mobile devices that are used for edge computing, and they are not always connected to the cloud. So this detached model of language model execution is definitely paving the way to use SLMs in these different applications. So they keep the data within the device and are great candidates for use cases where privacy or latency or other concerns in sending the data to the cloud. So can you talk about how SLMs have come about? I know you've been focusing on this for some time. And what are the pros and cons, if anybody in our audience, that are new to SLMs? So how do these small models compare to the large models? And what are the pros and what are the cons of the small models?
So first, just to start, let's define what constitutes a small language model. And the reason why I bring that up is because my own definition has changed. So if you asked me 3 months ago, what is a small language model? I had literally a slide that I presented at an AI conference in London where I said, and I've been saying that for a few months, a small language model is a model that's generally lower than, 7 to 8 billion parameters, because quantized, you can run that on a local machine. But then I had, as one of the bullet points, but this definition is subject to change when the models get better and also when the hardware gets better. And so lo and behold, I'm going to have to change that definition now, because and we're going to get to this, but using the latest AI PCs that's out there in the market today, we are currently running experiments where we are able to run, up to 14 billion parameters. That's like the latest that I've been experimenting with, just as easily on an Intel-based AI PC as I can like a 7 billion parameter a model on the Mac. quantized all, of course, but that would be quantized like GGREF versus quantized OpenVINO for the Intel. So that size is changing. So that's actually really, really interesting and exciting. And then that is coupled with the fact that the models themselves, the small language models, are getting actually really, really good. They're getting better by the week practically. And that is what's making all this innovation possible. So between the small language models getting really good, and then the fact that they are now being able to run on literally just a commodity laptop that are out, that will be, I don't know what the MSRP is, but one of the earlier versions of the Intel laptops we purchased for like $1,100 from Dell this summer. And then I think the Lunar Lakes are just coming out. So I haven't purchased one like for myself yet, literally, but we have a test machine that we've been able to use. So it's really exciting to see the small language models getting exceptionally good, and then the hardware on the edge device side getting exceptionally good, so that, the definition of small language model is changing. And then if you kind of add to that mix, like the innovation in the way that we're able to train these small language models. So since you mentioned like smartphones, I'll talk about, the Apple Intelligence that's coming out at the end of this month. Apple Intelligence, it's a 3 billion parameter model that's going to be, I think, on device. And then if it's larger, they're going to access it on the cloud. But that is made possible by pruning a 6.4 billion parameter model. So like they took a larger model and they pruned it, which means they basically took away some of the parts that they didn't think that they needed. And then they turned it into a 3 billion parameter on-device version. And then between pruning and then coupling that with distillation techniques, NVIDIA did both pruning and distillation to come up with their Minitron like in July or August. It's really exciting. So there's so many innovations around small language models that are happening that I'm not even sure that you can say that necessarily that large language models per se are better, because I would have to say, tell me what the use case is and tell me what the task is, right? So actually for a given task, I actually would have to say, I'm not sure. I am honestly not sure. Given the fact that they're so efficient and you can train them to be so specific to your use case, I actually think that there's arguments to be had on both sides.
That's a great point. Yeah, use the right size model for the right problem, right? So also, like you mentioned, by leveraging these small models with the company's proprietary data, which is kind of more specific to their domain, the accuracy has to be comparable with a large model, right? So
that's right. So in the NVIDIA study that they released in July, they were able to basically use 40 times fewer training tokens to come up with their Minitron. That's less than 3% of what it would take to train even from scratch, a small language model. If you keep taking that concept and you keep applying it, distillation plus pruning, and that resulted in a model that was 16% better, apparently, than a model the same size trained from scratch. So you take all these innovations and then you keep fine-tuning it with your own data, and then combine with the fact that you can run this on a laptop, and not a special laptop, just a laptop, like an AI PC, coming soon to, a desktop near you. I think it's really exciting. And you now no longer need a GPU farm. You don't need IT, to go spend millions and millions of dollars on separate GPU clusters. I think that's really exciting. That's truly democratizing AI and use cases. So I'm really excited about that. And I think that's going to be just revolutionary, and it's going to blow open the AI use cases that we have available today. And kind of I guess, one of the things that you and I wanted to talk about were possibilities, right? What is possible now if everybody has access to these AI models on their laptop? What is possible compared to before? And I think before, some of the trough of disillusionment or, the winter of discontent around AI is because we were really thinking about these use cases with a capital A, capital I, the killer use case, right? And I think that, going back to my story about why I was motivated to start AI Bloks and LLMWare, it was in these micro day-to-day tasks. I just needed help. I wanted something to do these, help me with these day-to-day tasks that would save me, a couple of hours a day or an hour a day. And maybe I wouldn't even use it every day, but it'd be so amazing to have that tool, right? A tool that I can used to very easily query my documents, chat with it, and not have to worry about data privacy, not have to worry about data leakage, data copies, because like that is every enterprise's nightmare. Obviously, you don't want data copies like sitting around everywhere. But, how are your workers working? They're already working on the laptop. Everybody's distributed. So, everybody like has access to laptops. So if you can like really bring AI to where they are at their fingertips, I think that blows open a whole bunch of use cases and truly fulfills the promise of AI, which is like worker productivity, right?
Makes sense. Yeah, actually, I have recently tried Olama with the V3, Microsoft V3 model, and I can definitely see the difference. It was obviously a lot faster than downloading a large model and run it locally, right? So definitely, I have not tried it with different use cases, but I could see the performance difference. And this was on my laptop, which is by no means, the fastest in the world, right? So you mentioned about these new models are going to democratize the use cases. Can we talk a little bit more about those use cases? Like what specific use cases you are seeing where small language models are being preferred to other alternatives?
So like just to start, let's just start with the most basic use case. Like, just things like finding information in your documents. You have an 80-page contract you need to look through. Who wants to look through an 80-page contract? I mean, you just want to find one or two pieces of information. If you needed to look through it, it's probably on your laptop somewhere. You have access to it. You would just upload it into your own laptop, like just literally just upload the file into the model, which is all running locally. So you could even run it air gap. You don't even need access to Wi-Fi because you're literally taking the model, like it's the models on your device. You could start to query it, just ask it questions. You could do summarizations. And then you could do SQL queries. Like if you have a large complex spreadsheet, like that's never any fun to query those. It's like SQL queries. And so all these kind of what I call micro tasks, but that's like part of everybody's day-to-day like working life, I think could all be automated. A voice recording, you can have that transcribed, and then, a meeting, and then you could literally just start to query that, summarize that, have it rewrite things for you. But now you no longer actually have to worry about any data privacy issues. So if you were to do that exactly, like take a contract, let's say you're in HR, you have an employment contract, and you just want to look up some information. How many, holidays did we promise this employee as an example? You could never, or I don't think that you should. Every company's policy is different, but I don't think you should be taking that agreement and uploading it to some cloud, that your company has not authorized. But now if that model is sitting in your laptop, it's literally just secure and it's not going anywhere. There are no data copies, just an example. But that's a very basic use case. And then what we're more seeing now is that with the agent workflow, you can easily create like a very simple workflow to automate. So one of the examples that we have is, let's say you're a financial analyst and you have an article that you're looking at and you just want to get, like produce a whole range of reports, like get a background description on the company. You want the latest stock price. You want its historical stock price. You could even have it do like an API call to Yahoo Finance as an example. If you wanted to do that, you can have it look up information on Wikipedia as an example, or other APIs that your company allows. You can do that. Just have it like really just grab that information and put all that into a report for you, and it just gets you started. So it's really supposed to be like a co-pilot for your everyday working life. And I think that is the promise of AI. So capital A, capital I, but like, not this big behemoth use case that nobody has access to, that only IT does. And, you can't also have 10,000 employees bombarding IT with their individual use cases, right? Like that's just not going to fly. So we want to really bring it to the user on their device.
Definitely. Also, I see the RAG, which is kind of one of the interesting outcomes of this, right? So where you have a base model, which can be a large model or a small model, and then you basically train the model with your company's private information, and then you can use the model to ask questions that are specific to your business domain. So do you see small models and the RAG are a better fit and made for each other, because you can start small and then enrich the model with your own business domain data, and then now you can use it like you said, on a commodity hardware and make it available for everybody in the company?
Oh yeah, no, absolutely. So with RAG, because of the loss in the middle problem anyway, like large models are not necessarily better at all for RAG. And I think, we were on a podcast earlier where we talked about that. And I believe even Mandy Gu had a personal experience with that. And it's just many, many studies have shown that. So it's not like, large language models are designed for complex RAG. And so the key to successful RAG deployment is just in the workflow, just making sure that, from document ingestion to all the way to the inferencing, that chain is handled accurately. So yes, no, absolutely. But then if you combine with that, like let's say a specialized embedding model that really understands your domain, just as an example, some in the middle of that, or if you don't do something as complex as that, that would be like for a much larger application. But like on device, you can really just upload the document, start querying it, and with very, very fast inference speed. And it's, especially with the new AI PCs that have the integrated GPU, the performance difference, even compared to what we were previously seeing on the Mac M3, is astounding. And, who knows what'll happen when Apple comes out with their new chips for sure. Like, I haven't seen that, so I can't say. But for now, even on the older Intel chip, which is the Meteor Lake, I can tell you that the difference between running PyTorch version of a model versus the OpenVINO GPU is like 115 seconds to 15 seconds difference for like a 21 question inference test for a 1.1 billion parameter model. So you can get like sub-second response times if you're matching the right inferencing technique with the right hardware. So there's so much going on in this space, but the net of that is really AI is coming to you. It's coming to you at your fingertips. So that's super exciting.
Well, I think that's the best way to explain, right? Bring the AI to the people who can get a lot of value out of that instead of sending the data to the cloud, right? Also, quickly, you mentioned about the previous podcast. That is the AI, ML, and data engineering trends report that we recorded back in August. So I'll make sure that we link to that as part of this podcast, and so our listeners can reference that as well and learn more about it. And then regarding the use cases, right? Just continue that use cases discussion. You mentioned about also with your attorney background. How do you see these small models, especially on the PCs, being used in applications like auditing or compliance? So how can you make it more built-in and enable those use cases to be more proactive? So compliance by design, right? Regulations by design rather than by accident. How do you see that?
So maybe because of my background, what we built into what we are doing for our commercial application, but I actually think that this has to be in everything that we do in terms of AI, are features related to compliance and auditability, AI explainability, not to mention guardrails, of course, like PII guardrails. But with respect to, I'll just start with AI explainability. And this is where I think small language models shine. And we are working with a use case in a large bank. And the part that they actually found very interesting that they really liked about this, the way to do this with small language models, is that if you're chaining a workflow, designing an automation with not prompts, but small SLMs, function calling SLMs that are basically outputting Python dictionary. So you can have, let's just say you ask it a question, and if it's yes or no, then like creating decision trees based on the model inferences and the answers. In that case, because like you have visibility to every single step, because like, oh, the model here at this point said yes or no. Let's just say, is this like a gold high level customer? Yes or no? And then you could kind of look at the logic. And if somehow there is any fault in the decision tree, then you can kind of see where exactly that fault is, as an example, and you can course correct, right? You can see where the mistakes are being made because you're really crystallizing the rationale behind how you are designing your workflow, very much almost like coding or software engineering, right? Whereas if you have like a really large language model that you're using with a lot of prompt engineering, this is not to knock prompt engineering. I'm just kind of explaining the difference. You actually can't tell like where, if you have an outcome that you're not happy with, where in that process did it fall apart? For instance, like where did the model like make the wrong inference that led to this outcome that you're not happy with? So you don't have visibility to that. So I think that's one of the big differences too, from an enterprise perspective, is if you can have visibility to every single step of, the AI explainability is you can see actually, we can expose like what are the options that the model was considering when it gave you that answer and what is the option that it ended up choosing. And so you can see that at every single step of the process. That is truly, I think, so critical to, especially when you're trying to deploy new processes, for everyone to understand, like, what is this model doing at every step and where is it making the right or the wrong decisions? because I mean, I think that there are very, very few instances where something's going to get it like right 100% of the time, like right out of the box, right? So we're just trying to do this in a very systematic, observable way. So I think that observability factor, explainability factor is really critical. And then because you have so much data and so much information, every single interaction, all of that is being captured, right? So every single inference is captured. Every single decision is being captured. So for auditability purposes, for compliance purposes, you have, all the data you could possibly need for every kind of question your auditors or compliance officer might have. So I think, for an enterprise, the unknown, like, I don't know how it got there. Oh, geez, like, what are we supposed to do is like the worst answer, right? And you want to be able to, almost do a forensic report on where did it screw up, and let's see why, and let's fix that part. But if you don't know where it screwed up, how are you going to go fix that part?
Also, that visibility into every single step in the process. I mean, that's the auditor's dream, right? So they want to kind of know all those under the hood details, right? So that kind of helps.
Absolutely.
Before we jump on to the other topics on this space, let me ask you this. Like, I definitely see large models, they've been popular for so long. Small models are getting more attention for specific use cases, right? Like you said, even though they're smaller in size, not necessarily poor in terms of performance or accuracy. So are there any use cases where you either see in the future where both large models and small models in combination can be the best choice? Not the or, but the and.
Oh, yeah, no, absolutely. I really do. So, for instance, we had a very interesting conversation with an extremely, extremely intelligent gentleman. He's an architect at one of the Fortune 500 companies and really, really brilliant. And, we asked him, like, where would you use, because he's very leading edge and, has really experimented with small language models as well. So we asked him, from your perspective, where would you use a really large language model like an OpenAI? And he said, those models are really good at just preserving the context of these conversations. So for instance, when you're having a conversation with a customer, like the customer, even if the chat goes on for several days, just as an example, the customer never expects to tell you the same information twice. Like, that's just a no-go. So those large language models are great for capturing those conversations and just kind of keeping that context over days, over long sessions. And I think that's totally right. Because of the large context window, this is where, it could preserve the context and keep having that conversation. So for these, very important customer facing chatbots that can go on potentially for days and, be really prolonged. Yeah, no, I definitely could see that use case. But now, let's say you want to capture that information, that conversation, when that conversation is done, and you want to derive a lot of, insights and analytics off of that. And those insights and analytics don't have to happen in real time, right? So that can run in batch processes overnight on very inexpensive hardware. So basically, you can take that same chat and you can basically send that off to a new workflow that doesn't need all that capability. And I think any processes that can kind of run in the background, that's like, running hourly, daily, and a lot of enterprises have processes that run weekly, monthly. All of those things actually can, I think, very soon be run with small language models, training a whole bunch of them together, on CPUs.
Yeah, definitely. I think you explained it very well. So the small language models, going back to the popular use cases or patterns in machine learning, usually we do some edge on device analytics real time for either finding any defects or any other use cases in the manufacturing processes, and then send results to the cloud. So there can be offline analytics to further generate more insights. To use that analogy, like small language models can be really powerful on the edge. In the devices, they can do the local modeling and generate the insights, and that output can be sent to the cloud to train the large language models, which can be more intelligent because of that. And the output of the LLMs can be sent back to the small language models. And I see there can be a feedback loop between the localized small language models and the cloud offline large language models, kind of feeding each other and making each other better, right? So
Absolutely. No, absolutely. I think the future, especially for a large enterprise, will be a combination. But, what I think would be wasteful at this point would be to use a really large language model for everything. That's just like, I think that could be overkill and actually a tremendous waste of resources. But, not everyone actually knows that yet. So there are definitely people who will just unleash, of these behemoth models at everything. But I think many people are coming to realize that that is an absolute overkill and a waste of resources.
Yeah, that's a great point, right? For any organization, especially the startups, which are always constrained financially, right? So large language models may not be an option for them to start with, but they can use the small models, kind of learn the process, learn the solutions, and make sure that they are the right solution, and then invest in a bigger solution, right? So that can be a first step in the overall learning and adoption process for the companies.
Yeah, and then beyond that, even enterprises are extremely cost sensitive. At least the enterprises I speak with are extremely cost sensitive. They may be more cost sensitive than startups, to be honest with you.
Yeah, because they can fail big if they're not, right? So
Yeah, this is where enterprises are always looking for a cost efficiency. Like, I mean, really, and I think that's right that, you want to obviously not waste money and have great results for your shareholders. So I fully understand that. And then they really care about security, safety, and cost efficiency. And, I totally understand on every single front that, a solution has to deliver those to be useful to an enterprise.
yeah, especially during the exploration phase of the adoption, they can try these low cost, better performance, easy to run models, and then grow into the large models, right? So quickly, Nami, I want to kind of talk about the practical side of this discussion, right? So I know most of our listeners are senior technical professionals. They're probably itching to, try this out on their own laptops. So what kind of infrastructure or tools are required to adopt or try or explore small language models in applications? Like how can our listeners who are interested in trying out small language models on their own laptops, how can they get started? What do you see as the open source frameworks or other tools to get going with this?
I'm going to give you a nuanced answer now because it really depends on your laptop. And I wouldn't have said this up until 2 months ago, but I really have to emphasize this point sincerely at this point. It depends on your laptop. If you are using a Mac, then by all means, like use the GGUF quantized version and use, a solution like Ulama. However, if you are working on an Intel based machine, for example, then you should really work with OpenVINO. It's by far, like it's hands down. It's so even if you don't have the GPU version, just the CPU version, you should really work with the OpenVINO library. We support a lot of that workflow in LLMWare now, but you still have to download OpenVINO yourself to work with our library. And let's say it's neither Intel and it's neither Mac, then I would really work with Onyx, which is the Microsoft version, and it's like cross-platform. And in my experimentation, Onyx kind of is like the middle of the road approach. So for the same test on that same Dell machine, if PyTorch ran at 115 seconds for 21 questions, like for a 1 billion parameter model, on that same Dell, GGUF ran at 113 seconds, so basically negligible. So don't bother with GGUF, like don't even waste your time on an Intel-based machine. But Onyx ran at 65 seconds, while the OpenVINO ran at 15 seconds. So I see Onyx as like a really good middle-of-the-road approach if you have a non-Mac and non-Intel-based machine. If you do, like so far as I know, GGUF is the fastest way to run inferencing on a Mac, and OpenVINO hands down on Intel, including just CPU-based machines. I have a 4-year-old Dell machine that I thought was basically like destined for recycling. But using what we have right now that we've developed, it's giving me the same performance as an M3 in terms of inference speed. It's crazy. But we didn't know that you had to match the right software to the hardware. So please go check out OpenVINO. Please check out Onyx and not just stick to GGUF and realize, and I had somebody from Australia called me 3 days ago saying, why are these models running so slowly on my machine? And I said, let me guess, you don't have a Mac. And he's like, yes, you're right. I'm not using a Mac. I was like, okay, now this is what you need to do. So this is my public service announcement to everybody, please.
Yeah, don't throw away your old laptops, right? So they're still valuable, right? Yeah, thanks for that. It's easy to get going with these, right? So the other main area I want to focus in this podcast discussion is how the small language models are enabling the AI powered PCs, right? We talked about that a couple of times in this talk already. So how do you see like the small language models can operate at the edge, as they say, and they don't need to be connected to the cloud? So how do you see this evolution of the models enabling devices like laptops, smartphones? I mean, they can be IoT devices, right? It can be even sensors in a manufacturing plant or components in a autonomous vehicle, right? I mean, the use cases are limitless. So how do you see this, especially the emergence of small models, accelerating the power of AI PCs and the devices?
Oh, I mean, I think it's incredible. Just like true democratization of, bringing the power of AI to your fingertips. So, I think in the earlier podcast, I said, it's my dream and my vision that, AI should be as ubiquitous as like just regular software and as easy to use and maybe even easier to use. And I think that's happening. So we are definitely trying to make that happen. So we've developed a product called Model HQ where you don't need to know C++ to download OpenVINO. You don't need to know anything. You just like literally, it's an executable. You just download it and then you can run any of these OpenVINO models and it runs really, really blazing fast on your AI PC. And this is just a start. And this is just like us. So I think, this is like such early days for all the model development, the PC hardware development. I'm sure there will be better and better hardware. So where do I see this going is truly, I do really think that's the power of AI in, let's say, 3 years will be so ubiquitous. We'll look back at these times and go, gosh, do you remember we were even like talking about, like, oh, these small language models are new. No, at that point, it won't be new. It'll just be like software, at this point, right?
Or like, when you buy the toys, right, it says like batteries not included. AI will be so ubiquitous that the applications have to say, okay, this application does not include AI, right? So
No, that's right. I think it can power everything. And I mean, anyone who's played with, Gen AI knows like the power of being able to inference and the powerful capability and the fact that they're now coming in such small footprints, smaller and smaller footprints with all these like distillation and pruning techniques and combination and getting better and better and smaller footprints. And then the hardware getting better and better. So basically, even the definition of small language model changing, the fact that I can now say like, oh, I can run after we hang up, I'm going to this weekend try to see if I can run a 20 billion parameter model on a laptop. Unthinkable, right? Even like 3 or 4 months ago for me anyway. I'm sure there are like brilliant people out there who've already done it. But for me, it was like unthinkable. But the fact that I can even talk like that, but then the fact that you might not even need a 20 billion parameter model because these 3 billion parameter models are getting so stupendously good. It's really an embarrassment of riches at this point today, let alone what'll it be like 3 years from now.
yeah, definitely. I kind of see these small language models and AI powered PCs as like two sides of the same coin. They're so complementary. They're going to make each other kind of innovate, at a very fast pace.
That's right. And the price point of these AI PCs to me is really interesting. If you think about it, for the powerful capability that they offer, they're really inexpensive. And we were able to actually just turn one into like an inference server, just playing around with it. So the GPU capability is so powerful. So it's really, really, really cool what can be done with it. So I highly recommend everybody to check it out. I think the Lunar Lake version is coming out now for consumers. And, if you're at your local Best Buy or wherever they're available, like I just, just check them out. It's amazing, amazing.
Yeah, it's interesting. I was checking the Dell website earlier today, just kind of see what kind of desktops and laptops are available. You can get a gaming desktop with the GPU with NVIDIA RTX. I think that's like for like $1,000, $2,000. So very, I guess, very affordable. Relatively, right? So
yeah, no, absolutely. Compared to like having to reserve time on your cloud for A10, A100, H100, how much is that going to cost you, and how is that even accessible anyway?
So yeah, let's talk about some best practices, right? Definitely, I think the language models are evolving so fast. They're getting definitely more powerful and smaller in terms of the parameter size and not necessarily in terms of performance. Do you have any advice on any best practices for somebody who wants to use these? What kind of cautions they should be aware of?
So first, honestly, just start by trying. And my kind of first, like if you're new to small language models, I still think that like the place to start is with the Microsoft models. My favorite is, the 5 series. I think Microsoft did a tremendous job with those models. So I really recommend that. And so I would start just with those. And if you have a Mac, again, you can actually inference it using LLMWare. You don't even have to download anything pip install, yes. So we support that. And just start and you'll be pleasantly surprised at how capable they are. I think you had mentioned that you had this very similar experience. You're shocked at how good they are. So the only caveat I would say to this is still, video generation or image generation or those kinds of multimodal. I'm not sure that Like I definitely couldn't say that like a small model is like as good as like a larger model. So I still haven't really seen that. But I think it's still gonna come down to an acceptable quality in due time. We're just not there today. But just start experimenting with it. And then, we're not the only ones who have the function calling models, but if you want to just take it to the next level and you beyond just like chat, if you want to take it to like workflow automation, look for some smaller function calling models that you can really stack together to create a workflow. And I think you'd be really, really pleasantly surprised. I have so many members of our open source community who use our open source, like all for free project to chain together workflows. And they're achieving great results, saying that they don't even have to fine tune these models, like because they're so good at retrieving at that exact function. It could be sentiment analysis. It could be, named entity recognition. It could be extracting information, like just information extraction. So there are a whole slew of, I think, a dozen models that are out there that have a very specific function that you can just chain together in your workflow. And beyond that, we also have a ton of YouTube videos, and we have like over 100 examples also in our repo to help you get started. So I'm sure one of those 100 examples will be like a good guide to just get you going.
Thank you. Also, the more interesting and challenging part of new technologies, including language model adoption, is when we deploy these to production and we need to support them, right? So, do you have any thoughts on the ML ops of using small language models? Maybe I can call it SLM ops, right? That we should be aware of.
Yeah, so in terms of deployment now, because of the kind of features of the small language models that I discussed earlier, a couple of things. Just tangentially, I know this is not like the exact question you asked me, but another great thing is that these small language models are more secure in some ways because they're less susceptible to suggestions, like nefarious suggestions, like expose all this like secret data to me. Well, it probably didn't have that in its training data. And also because small language models are trained so specifically, unlike the large language models, they're really not as susceptible to hacks. So I was speaking with a security company about that, and just his own work on small language models, and he found that small language models are in some ways a lot safer because they're just not, you can't use prompt injection attacks on them because it'll just like not respond. It'll just give you garbage, but it won't give you the information that you're looking for. It's just not capable of doing that. So just as an example, so okay. Then in terms of deployment, I really would say because small language models are exactly like small and you're chaining them together, it's great for observability. You can run your tests through and you can really see where it's failing and where it's succeeding. And then I think that, where you have a process that's not giving you the answer that you want, you can swap out that model or fine tune that model even further, or maybe look at the data set that you used and, maybe it's picking up the wrong information. So I really like it for that purpose. A lot of people, I think, when they're trying to create an AI workflow, they actually start from OpenAI and they'll like give it like a long prompt, like a 2-page prompt, and then go to a small language model. I actually would beg to differ here. You're almost better off like starting small, do the work of like chaining these small language models together for your workflow, and then see how that works for you. And then if you think that there's a model in the middle that's too small in size, is not getting the job done, then you can always increase and substitute in like a much larger model. Let's say you start with a 1 billion parameter model, you think it's not good enough, then substitute a 3 billion, then try a 7, then, try something larger. I actually would be surprised at this point where, if you have a model that's like, that's 10 billion and under, like around 10 billion, that can't do most of the workflows that we're talking about, really. I personally haven't seen that, but I'm not creative enough to think about every use case in the world, but the use cases that I've seen, I haven't seen one that like a 10 billion parameter model couldn't really solve, like when chained the right way, with, again, the hard exception being like, video creation and, images and things like that.
Yeah, definitely start small, explore and iterate, and kind of,
Absolutely.
Sounds good. So on this topic, do you have any recommendations, online resources? We talked about a couple of tools, OpenVino and other ones, right? So do you have any other resources, especially like knowledge-based articles or tutorials that our listeners can check out?
So I always really like going to MarkTech Post for a lot of just leading edge AI research. If you really are into that and you want to see like the latest development in model training and what is going on in that space, if you are AI research inclined. And then believe it or not, like I love watching tutorials on YouTube. So we have a YouTube channel and there are a whole host of other YouTube channels that really expose like the latest in AI. And I like watching people, like their take on it. They show you their experience with it. And AI Anytime has a great channel. World of AI is always good about, kind of exposing like the latest like open source projects. And again, we have one. So and then I always follow Hugging Face's LinkedIn site just because they also really promote like some great new models. Most of them are small. And so Hugging Face on LinkedIn is great. So those are kind of the resources that I tend to follow.
And also, obviously, we have good information on our own InfoQ website as well, right?
Oh, absolutely. Actually, not because I'm on it, but I have to say, when I was doing research on the Apple Foundation models, I really love the content that I saw at InfoQ kind of describing, how the AFMs, the Apple Foundation models were created. And I thought it was a great article. So InfoQ, definitely.
Going back to your point about AI are becoming ubiquitous, and I'm seeing that on InfoQ content as well. We have these different communities for architecture, the DevOps, and so on, cloud and security, and obviously AI and ML. We are seeing a lot of AI-based articles in pretty much all of these communities. So it is kind of pervasive, right? So
the question is like, when is AI going to be just like a thing, like just a regular thing? Like no one's like excited about like, oh, I have my own website. Like no one cares anymore, right? Like, come on. So when are we going to reach the point where, like, yes, it's just understood that everything's just going to have the AI in it, just like you said.
Yeah, I think it's going to happen, but we have to look back and think about, back in like, I don't know, 2026, 20, whatever, right? I'm just picking a year, but then we'll say, that was when, the AI became like the part of the, the everything we do, right? So I think we won't realize when it happens, but, maybe looking back after that, probably we will realize that.
Absolutely.
So do you have any additional comments before we wrap up today's discussion? Anything else you would like to share?
No, I mean, thank you so much for having me on. I really appreciate it. And thank you, InfoQ community, for listening. And I really encourage you to keep experimenting and play around. And please visit my open source site, LLMWare. We are really pioneers in this space and we really try to pack in like an end-to-end solution. And it's really free for anyone to try out. So please give it a whirl.
Thank you, Namee, for very much for joining this podcast. It's been great to discuss the recent innovation in the language models and Gen AI space, which is the small language models, which, like you mentioned, have the potential to commoditize and localize the language model solutions so they can have a bigger impact on the software development community overall. And to our listeners, thank you for listening to this podcast. If you like to learn more about AI ML topics, check out the AI ML and data engineering community page on InfoQ.com website. I encourage you to listen to the recent podcasts, especially the one that Namee mentioned earlier, the AI ML Trends Report for 2024. We did the podcast in August, but we published the report last month in September 2024. You can learn about small language models, AI-powered PCs, coding assistants, and a lot of other trends. A lot of interesting topics there. We've been seeing a lot of activity on that podcast. So definitely check it out. Thank you, Namee. Thank you. Thanks, everybody.
Thank you.